Okay, think about this for a second. High above us, in what looks like the peaceful, silent dark of space, is the very backbone of our modern world. But that environment? It's anything but peaceful. Today, we're diving into the invisible forces that are a constant threat to our most critical technology. All right, so just for context, this is part 4 of a big 10-part series. It's all based on a really detailed report from the RFI detectives, who are a part of Virtualization Options LLC. We're zooming in on one crucial chapter today, just how vulnerable our satellite systems really are.
So, it all really boils down to this one question, doesn't it? We've built our entire global system for communication, for navigation, for information on this infrastructure up in orbit. But what's the plan for when the space around those satellites decides to, well, fight back?
To even begin to answer that, we first have to get a handle on the reality of what we're dealing with up there, in our fragile sky. I mean, just think about your day so far. Getting directions, checking the weather, making a phone call, maybe swiping your credit card. Almost all of it, in some way, relies on a signal from a satellite. It works so seamlessly that we just forget it's there. And we definitely forget how vulnerable it all is. So what is this threat exactly? We're not talking about asteroids or space junk today. No, the real focus here is space weather. And according to the research, it attacks our satellites in 3 main ways. First, there's this constant shower of high-energy particles bombarding everything. Second, you've got a buildup of static electricity that can be, well, catastrophic. And third, there's a really subtle but constant atmospheric drag that can literally pull satellites off course. For right now, we're going to focus on those first 2 because they're the ones that really mess with the electronics directly.
Now, here's what's so wild about this. You might be picturing some massive solar flare just frying a satellite. But the most common threat? It's microscopic. A single high-energy particle, maybe a proton from the sun, can zip right through a satellite shielding, smack into a microchip, and flip a single bit of data from a 0 to a 1. That's it. It's called a single event upset, or an SEU. And yeah, it sounds tiny, but that one little flip can corrupt mission-critical data, crash the entire operating system, or tell the satellite to do the completely wrong thing.
The next threat is electrostatic discharge. You know how you can build up static by shuffling your feet on a carpet? Well, the same thing happens to satellites as they fly through space plasma. Now, during a geomagnetic storm, that process goes into overdrive. If that charge builds up too much, and then suddenly discharges, it's like a miniature lightning bolt arcing right through the satellite's most delicate circuits. In fact, this is exactly what they think caused the total loss of the Telstar 401 satellite way back in 1997.
And look, these threats aren't just theoretical. They have real, measurable impacts on the systems we depend on every single day. Let's take a look at how this plays out with something we all use, GPS.
So, when a solar storm hits Earth's upper atmosphere, it churns up this layer called the ionosphere. For a GPS signal trying to get through that, it's like trying to see the bottom of a swimming pool while someone's splashing around like crazy. The signal gets all distorted and starts to fade in and out really fast. That's called ionospheric scintillation, and it can easily cause your GPS receiver to completely lose its lock on the satellites it's trying to track. And it's not just GPS that's at risk. Earth observation satellites flying in low Earth orbit can get their data corrupted, leaving these huge gaps in the imagery we need for tracking climate change or responding to disasters. Satellite phones, the last resort in an emergency, they can just lose their signal. And navigation satellites can have these teeny tiny clock errors that, down on the ground, translate into you being yards away from where you think you are. Basically, every part of our orbital network gets hit differently, but nothing is immune. And this is where it gets personal. Because these problems, happening hundreds or even thousands of miles up, they don't stay up there. All those errors, the data corruption, the timing glitches, they basically ride the radio waves all the way down from orbit and end up right in the palm of your hand.
Ever had a call just drop for no reason at all? If you were using Voice over LTE, that system depends on super accurate timing it gets from GPS. One tiny glitch in that timing signal, and poof, your connection is gone. And it's not just the signal. Those same energetic particles that cause SUs in satellites, well, when they hit our atmosphere, they create a shower of secondary particles that can actually reach the ground and flip a bit in your phone's processor. And the result? A random app crash, your whole system freezing up, or that incredibly frustrating spontaneous reboot.
The source report just puts it perfectly. The next time your phone glitches out, just stop and consider the absolutely insane journey that might have caused it. A particle from the sun that traveled 93 million miles to flip a single bit in your system's memory. That's a mind-boggling link between the cosmos and your daily annoyances.
So you're probably thinking, surely we've built defenses against this, right? And yeah, we have. But there's this constant tug of war going on between protection and performance, and it's creating all kinds of new vulnerabilities.
So on one side of the balance sheet, you've got incredible tech. We're talking radiation-hardened chips, error-correcting code, all the good stuff. But on the other side, the pressure to innovate and push costs down means a lot of commercial satellites are launched with basically off-the-shelf electronics that have minimal protection. It's a constant high-stakes balancing act between making something resilient and making it affordable.
Which really just leaves us with this final, crucial question. Our technology lets us do these amazing things, connecting the whole globe in ways we couldn't even have imagined a few decades ago. But in our big race for faster, cheaper, and more powerful systems, have we forgotten to make them strong? Is our incredible, fragile network in the sky truly resilient enough for the next big storm? That's something to think about.